Hello everyone, today we are going to go through correctness and the loop invariant, which is a problem under sorting section of algorithm of Hackerrank. So without wasting time, let us have a look on the problem statement. So I will not go deeper into the problem statement, I will just summarize what you're supposed to do here, right? So here we have an implementation of the insertion sort algorithm, and we are supposed to analyze the code and then solve it to make it work as the insertion should work exactly by using the concept of loop invariant. So globally, that is the need of this problem. So the first thing we need to know is to understand how does the insertion sort work, right? And then we have been working with the insertion sort with the two previous videos. So if you are not yet familiar to that, don't hesitate to check them. How does it work? How does the insertion sort work? Basically, the idea of the insertion sort is that you consider a subarray being sorted, and then you insert an element into that subarray in such a way that the subarray will remain sorted. So globally, that is the idea of the insertion sort. And but for it, so you need to consider, like, maybe let us take this one for instance. You're going to consider this array being sorted is one element, so it's eventually sorted, right? And then you need to insert this element in such a way that the array consists of the previous subarray plus the insert element remains sorted. And then for it, you need to insert it at the first position, and then the same here, the same until at the end you have your array being sorted. So globally, that is the concept of insertion sort. Now that we are aware of how the insertion sort is working, let us analyze the algorithm, like the input that we have, and then see how it has been implemented. So here in this algorithm, we can see that we receive as input an integer n, and we receive an array. N is the size of the array, right? Now we move to the first element till the end of the array, which is nice. And then for each of the element, we keep the element into a variable called value. Then we take an index, which is the element directly before the element that we keep the value here. And then we now have a while from that element, like we have while the index is greater than 0 and the value is less than the element at that position g. Then we perform this operation and we decrease. So we are kind of moving from that element till the first element by looking where we can insert the element. That is the use of this condition. And then at the end of the array, we will now insert the value, like the element that we took at the beginning, at the position g plus 1. And then this function is used to print the element, to print the sort array at the end of the operation. So this is what we have, but unfortunately this code is not working. What is missing? How do we fix that? So we are going to make use of the concept of invariant loop. So invariant loop state that for this case, for instance, the invariant loop will be used to confirm that at the beginning of each iteration, the array is sorted, and then at the end of the iteration, the array remains sorted, right? So the invariant loop is used to make sure that a condition is respected at the beginning of iteration, and the condition remain respected at the end of the iteration. And in this case, it is the state of our array being sorted. So what is missing here? How do we find out what is missing? From the explanation, we say, okay, we need to keep the value that we want to insert into a variable, which is what we are doing here. After that, we need to start from the element directly behind. So it's correct. So if we take this element, to find out where we need to insert it, we need to take the element directly before, which is I minus 1. So here we are still correct. And then here what we are doing, we say we are going to loop from that element till the first element in the array. So if g is greater than 0 and value less than r of g. So there's a problem here. We say if g is greater than 0, what about the first element? Because we are 0 base index in C++, so g can be 0. So the first element needs to be taken in consideration. That is already a flag. So if you run this, what do we have? That is a flag because we are not taking the element 0 in consideration. We will see that this is our output 4, 1, 2, 3, 5, 6, and this is the expected output. We can see that we have an array which is sorted and the first element is not sorted. And exactly it's not sorted because we are not taking that element in consideration when looping here. So what if we take it in consideration? We say, okay, if g is greater or equal to 0, then we should dive into the loop and find out if we need to perform a swap or not. So let us run again. We have a congratulation now. So by changing this, we make the array sort after the iteration. Let us submit and see what it gives. Nice. So this was our approach of solving this. So basically at the end of this, you may ask yourself, what is the complexity of this algorithm? This algorithm is big of n squared, and then it is the time complexity of the insertion sort algorithm. Stay tuned for the next video. I hope you enjoyed this. Don't hesitate to leave me a comment in the comment section. I'll be really happy to interact with you regarding this. Stay tuned. See you. Ciao.